Chapter 3. In Chapter 3, what is meant by explain each letter and does it mean in the expression 3H2SO4? What is meant by 3H2SO4? Okay, so what is meant by 3H2SO4? 3 refers to the number of molecules. So we have 3 molecules of H2SO4. In each molecule in H2SO4 we have 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. So again, what is meant by 3H2SO4? 3 refers to the number of molecules. Each molecule contains 2 atoms of hydrogen, 1 atom of sulfur, 4 atoms of oxygen. Explain this equation in words. 2H2 plus O2 gives 2H2O. 2 molecules. So the number before any element, this is the number of molecules. 2 molecules of hydrogen molecule reacting with oxygen molecule to form 2 molecules of water. So again, 2 molecules of hydrogen reacting with 1 molecule of oxygen to form 2 molecules of water. Number 3. What is the atomicity of Na, NO, HCl, NH3, CH4, CO2? So what is the number of atoms? There is a difference between number of atoms and number of elements. What's the difference between number of atoms and number of elements? For example, if we have H2SO4, what is the number of atoms and what is the number of elements? Number of elements refers to the number of types. So we have hydrogen, this is 1 type. Sulfur, oxygen, so we have 3 types, 3 different elements. Hydrogen, sulfur, and oxygen. How many atoms? 2 hydrogen, 1 sulfur, and 4 oxygen. So we have 7 atoms. So again, what's the difference between an H2SO4? How many atoms and how many elements? H2SO4. How many atoms and how many elements? How many atoms to count them all? 1 times 2, 2, plus 1 is 3, plus 4. So we have 2 plus 1 plus 4, the total equal to 7. So we have 7 atoms. In case of elements, how many elements? The types, we have hydrogen, we have sulfur, and we have oxygen. So we have 3 types of elements. Another example, if we have NH3, how many atoms and how many elements? Try to answer. How many atoms and how many elements? You can open your mic or you write on the chat. How many atoms? Okay, you're right. 4. How many elements? 2. Excellent. So in case of Na2CO3, how many atoms How many elements? Seven atoms. Okay. Three elements, but not seven. You must count them again. Three elements, you are right. But how many atoms? Six, you are right. Excellent. Okay, so we have four atoms. 1 plus 3 to be 4. We have 2 plus 1 plus 3, so we have 6. The type of elements, we have nitrogen and hydrogen, 2. Sodium, carbon, and oxygen, so we have 3. So we have a difference between atoms and elements. After that, Ne, how many atoms? Ne, 1. NO2. How can we know these two elements or one element? In case of C capital O small, this one element, cobalt. If we have C capital O capital, carbon monoxide. So in case of capital and small, this one element. Capital, capital, this means that two elements. Okay? One element to be like that. Capital small, like sodium. But capital, capital, this means that two elements. So neon 1, NO2, HCl, write in the chat. How many atoms? Okay, you are right. 2. NH3. Okay, 4, you are right. CH4. 5. CO2. 3. Excellent. Molecular and simplest formula. Empirical and molecular formula. The empirical formula is the simplest form, so we must simplify, give the simplest form. Simplest form, you can make division to the smallest value, but you must have all to be whole numbers. There is no decimals or fractions. So 6 divided by 6 to be CH. C2H6 divided by 2, so it will be CH3. Excellent. NaNO3 as it is. SiO2 as it is. CH3COOH, you must write it in the molecular formula. How many carbons? How many carbons? 2. How many hydrogen? 4. How many oxygen? 2. So this is a molecular formula. Simplify. So it will be CH2O. C6H12O6 ratio 1 to 2 to 1. So it will be CH2O. So we have different molecules, but the empirical for both the same. Ratio 1 to 2 to 1. After that, write the formula of sulfur dioxide. Sulfur as oxide refers to oxygen. Di refers to 2. Tri, 3. Tetra, 4. Penta, 5. Hexa, 6. Hepta, 7. So for example, sulfur oxide O, dioxide O2. So again, sulfur dioxide SO2. So can you write the formula of sulfur trioxide? Sulfur trioxide, write it now, fast. Okay, excellent. SO3. Phosphorus P, chloride Cl. Any element must have "ide" at the end for the second element. So the first element as it is, sulfur, phosphorus, but "ide" for the second one. Okay, penta refers to, so the formula, no, yes, excellent, BCl5, not 4, you are right. Okay, so BCl5. Di refers to 2. Nitrogen, penta, oxide. So rearrange nitrogen, dinitrogen, N2. Pentoxide, O5. And N2, O5, not 2NO5. N2, 2. Why? Because if we have any number here, refers to the number of molecules. But here refers to formula, valency. So you must write the number after element, not before. Dinitrogen pentoxide. Okay, another examples. Sulfur, hexa, chloride. Make it now, fast. Sulfur, hexa, chloride. Excellent. Excellent. Sulfur S, chloride Cl, hexa refers to 6, SCl6. Okay. Carbon tetrachlorides. Try to make it now. Carbon tetrachloride. Excellent. CCl4. Carbon C. Chloride Cl. Tetrasphore. CCl4. Okay. Give the name of HiCCl4NO2 in case of two elements like Hi. So the first one you can write it as element and the other one have "ide", like hydrogen iodide. If we have any number, so you write element, then the number of the second element, then "ide". So carbon tetrachloride, nitrogen dioxide. Okay, what is the name of SCl4? Sulfur tetrachloride. You are right. Okay, PF5. What is the name of? Phosphorus pentafluoride. Excellent, bravo. Okay, so how can we write the formula or the naming or formula? So again, sulfur dioxide sulfur is the element S. Oxide refers to oxygen. Di refers to tri, 3. Tetra, 4. Penta, 5. Hexa, 6. Hepta, 7. So sulfur, di refers to 2, oxide. Sulfur trioxide, SO3. Phosphorus, chloride, Cl. Penta refers to 5.
Recording in progress.
So again, dinitrogen pentoxide, nitrogen, dinitrogen, oxide, pentoxide, N2O5. Gives the name of, we said that, halogen iodide, carbon tetrachloride, nitrogen dioxide. Okay. After that, what is the mass of atom of silver in AMU? In the break table, you will find that we have two numbers in the break table. Like, for example, if we have sodium, 1123. So in case of what is the mass of the weight of sodium, the mass number refers to the number, sum of protons plus neutrons. So the huge number. So silver, 108 AMU. This is from break table. Know the mass of 6.02 times 10 power 23 atoms of an element. What is the mass of 6.02 times 10 power 23 atoms of sulfur? In case of calculations, you must know that. In any calculations, you must know that. What is meant by mole is the mass or molar mass. Moles refers to the molar mass. Why? Because molar mass is the mass of 1 mole. For example, write the molar mass of each of the following. Na2CO3, H2SO4, C2H5OH, CaCl2. Knowing that the numbers from break table, Na23, C12, O16, S32, H equal 1, Ca40, Cl35.5. The first one, right? Calculate the molecular mass of each of the following. What's meant by molecular mass? Mass of 1 mole. So how we calculate Na23? How many atoms that we have? 2. So 23 multiplied by 2. Plus, between elements we have plus. Carbon 12 plus O equal to 16 multiplied by 3. So it is equal to, try to make it now. How much is that? 23 multiplied by 2 plus 12 plus 16 multiplied by 3. Yes, use calculator. 106. Okay. So by the same way, try to make them all. H2SO4, C2H5OH, CaCl2. You have 2 minutes, all of you now. Make it on a calculator and then write the answer. H2SO4, H1 times 2 plus 32 plus 16 times 4 is equal to 98 gram. C2H5OH, 12 multiplied by 2 plus 1 multiplied by 5 plus 16 plus 1 equal 46 gram. 40 plus Cl 35.5 multiplied by 2 is equal to 112. Okay. After that, to calculate number of moles. Number of moles is equal to mass over molar mass in case of solids equal number of molecules over Avogadro's number 6.02 times 10 power 23 in case of particles equal volume decimeter cubed over 22.4 at STP, standard temperature and pressure. So how can we know this? Mass over molar mass, volume over 22.4, molecules over Avogadro's. It depends on the gallons. In case of solid, how can we know this is a mass? By the units, gram, kilogram, ton. So this is a mass. In case of centimeter cubed, milliliter, liter, decimeter cubed, so this is a volume. And in case of centimeter cubed or milliliter, to be over 1,000 to be decimeter cubed. Okay. Number of molecules over Avogadro's. In case of we need atoms, multiplied number of atoms to obtain atoms. For example, calculate the number of moles in each of the following. Number 1, 23 gram of ethanol. Knowing that C equal 12, H equal 1, O equal 16. Number 2, calculate number of moles in case of 48 decimeter cubed of oxygen gas at STP. Calculate number of moles in case of 3.01 times 10 power 23 atoms of sodium. In the first one, number of moles, we have gram, so we have a mass. So number of moles is equal to, if we have a mass, mass over molar mass. So it will be mass over molar mass is equal to 23 over the molar mass. Molar mass of C2H5OH is equal to 12 times 2 plus 5 plus 16 plus 1 equal 46 gram. So 23 over 46 to be equal to 0.5 mole. Number 2, 48 decimeter cubed of a gas at STP. So we have volume decimeter cubed over 22.4. So number of moles is equal to volume decimeter cubed over 22.4 equal 48 over 22.4. Number 3, number of atoms or molecules, any particles. So number of moles is equal to number of atoms over Avogadro's number, 6.02 times 10 power 23 is equal to 3.01 times 10 power 23 over 6.02 times 10 power 23 equals 0.5 mole. So number of moles is equal to mass over molar mass in case of solids. How can we know this is a solid? From its units, gram, kilogram, ton. Volume decimeter cubed for a gas at STP. Volume decimeter cubed over 22.4. Number of molecules over Avogadro 6.02 times 10 power 23. In case of, if we have a mass and we need to obtain volume, or if we have a mass and we need to obtain molecules, you must know that 1 mole of any compound or any substance contains number of molecules which is equal to 6.02 times 10 power 23 equal volume equal to 22.4 at STP equal mass is the molar mass. So again, 1 mole of any substance contains mass which is equal to the molar mass. Volume at RTP or STP, which is equal to 22.4. Number of molecules, which is equal to 6.02 times 10 power 23. So, for example, if we have 12 grams of carbon, how many molecules or atoms of carbon? 6.02 times 10 power 23. If we have oxygen, volume of oxygen 22.4, how many molecules? 6.02 times 10 power 23. So 1 mole of a substance contains mass, which is equal to molar mass, volume at STP, which is equal to 20.4, molecules, which is equal to 6.02 times 10 power 23. Okay. What is the mass of 6.02 times 10 power 23? 6.02 times 10 power 23, it means that 1 mole. So this means that what is the molar mass of silver? So it's equal to 108 grams. What is the mass of 1 mole of silver in grams? Also 108. So what is the mass of 1 mole? What is the mass of 1 mole also? The same. Find the number of moles and number of atoms in a given mass of a substance. How many moles and how many atoms are present in 11.5 grams of sodium? So we need to obtain, we have a mass. So number of moles equal mass over molar mass is equal to 11.5. From periodic table, you will find that sodium equal 23. 11.5 over 23 is equal to, try to make it now, 0.5 mole. So this how many moles? After that, how many atoms? Number of moles, number of atoms is equal to number of moles multiplied by Avogadro's number, 6.02 times 10 power 23, equals 0.5 multiplied by 6.02 times 10 power 23. So it is equals 3.01 times 10 power 23 atoms. So again, a number of moles is a common. This is the number of moles, okay? Equal mass over molar mass equal number of molecules or atoms over Avogadro's. So if we have a mass and we need to calculate molecules, how can we make mass over molar mass? Okay, you get moles. Moles multiplied by 6.02 times 10.23. So again, if we have a mass and we need to obtain molecules, how we get molecules? Mass over molar mass to get number of moles. After that, moles multiplied by Avogadro's to get molecules. How many moles, molecules, atoms are present in 2 grams of oxygen? Again, how many moles, molecules, atoms in 2 grams? So the first point you must have, as we said, number of moles is equal to mass over molar mass equal number of molecules over Avogadro's. Okay, so we have a mass over molar mass to get moles, multiplied by Avogadro's to get molecules, multiply number of atoms to get atoms. Try to make it now. So 2 over oxygen. Oxygen O2. An oxygen gas or any active gas diatomic molecule O2. So 2 over O equals 16. So 16 multiplied by 2. So 2 over 32 is equal to how much is that? 0.0625. After that, this is the number of moles, mass over molar mass to get moles, multiplied by 6.02 times 10 power 23. You get molecules. How can we get atoms? Multiplied by 2. Why? Why we make it multiplied by 2? Because we have number of molecules is O2. This is the number of molecules. How many atoms in O2? 2. So the first thing is that mass over molar mass. The molar mass 32, not 16. O2 to get number of moles. Number of moles multiplied by Avogadro's to get number of molecules. Number of molecules multiplied by number of atoms inside the molecule is 2 to get that. So in case of we having number of moles multiplied by molar mass to get the mass, multiplied by Avogadro's 6.02 times 10 power 23 to get number of molecules. And if we need to get number of atoms, multiplied by the number of atoms inside the molecule, multiplied by 22.4 to get volume decimeter cubed at STP, standard temperature and pressure. So the first thing is that to get number of moles, how can we get the number of moles? Mass over molar mass, molecules over Avogadro's, volume decimeter cubed over 20.4. If we have number of moles, the second step, multiplied by molar mass to get the mass, multiplied by Avogadro's to get molecules, and then multiplied number of atoms to get atoms, multiplied by 22.4 to get volume decimeter cubed. How many moles do 3.01 times 10 power 23 molecules? Number of molecules. So number of moles is equal to number of molecules over Avogadro's. So number of molecules over 6.02 times 10 power 23. So we get 0.5 moles. What is the mass? So we have moles, 0.5 multiplied by molar mass. Molar mass of H2S from periodic table, H1 times 2 plus 32. So we have 34, 0.5 multiplied by 34. So it's equal to 17 grams. So again, in case of H2SO4, NH3, and Na2CO3, the number of atoms and the number of elements. Number of atoms to count them all, although they are similar or different, like H2SO4, 2 plus 1 plus 4. So although they are similar or different, you are count them all. But in case of number of elements, so you must have only for the type of elements, hydrogen, sulfur, and oxygen. So we have 3 elements. NH3, 4 atoms, but 2 elements. Na2CO3, 6 atoms, but 3 elements. Molar mass, mass of 1 mole, like Na2CO3, H2SO4, C2H5OH, CaCl2. Na, 23 multiplied by 2, plus 12 plus 16 times 3, 160 grams. This is the molar mass or mass of 1 mole. So number of moles is equal to mass over molar mass. In case of solid, how can we know this is a solid? Gram, kilogram, ton. So if you have any mass, mass over molar mass. If we have molecules or particles or atoms over Avogadro's. If we have volume decimeter cubed at STP over 22.4. After that, calculate number of moles of each of the following: 23 gram mass over molar mass, 48 decimeter cubed over 22.4 gas at RTP, number of atoms over Avogadro's. 1 mole of any substance contains mass equal molar mass, volume at STP equal 22.4, molecules equal 6.02 times 10 power 23. The number of moles, if we get the number of moles multiplied by molar mass to get the mass, multiplied by Avogadro's number to get number of molecules, and if we need to obtain the number of atoms to get multiplied by the number of atoms, multiplied by 22.4 to get volume decimeter cubed at STP.